All right, everybody, it's been another interesting day for space weather, to say the least. The geomagnetic storm is looking like it's subsiding, and at the same time, a solar energetic particle event is occurring. A massive coronal mass ejection to cover. You may notice some action on the western limb. We'll talk all about it today here at the Smash News Network, least busted name of news. This is the past 24 hours in ionized helium from SDO, the Solar Dynamics Observatory. Let's take a closer look at that western limb where the action has been occurring. Again, there was a coronal mass ejection generated from this series of events. Also a solar energetic particle event where relativistic particles, solar protons, strike the Earth at a significant percentage of light speed. You can expect the most likely place to see a large solar flare continuing to be in the northwestern limb. The eastern limb has some significant sunspot players as well, as you can see here. And that 304 angstroms wavelength is just totally sweet. That is some good stuff. The story of the day also continues to be solar filaments. We've got huge plasma filaments. You can see some of them up there to the west of the Earth scale. Also south of the Earth scale, there are some giant filamentary structures. We'll show you more detail on that later in the video as well. Also, a crown prominence still hanging out at the south polar region. Exciting stuff going on, indeed. So, now, by the way, folks, if you're new to the channel, do yourself a favor and press subscribe. And even if you're not new to the channel, if you haven't seen our shorts, check them out. Our shorts are a great way to share our videos with your friends and foes, people who have attention spans of less than 1 minute. Of course, YouTube is trying to compete with TikTok, so that's part of the reason why the videos are in this portrait orientation instead of landscape mode. It's to be displayed on smart devices, so surprisingly low number of views in the past couple of days, despite incoming space weather. So it makes no sense. We went from like 3,000 views to like 300 views, and it just, again, it makes no sense. So press that share button. If you're new to the channel, press subscribe. Leave us a comment. Tell us how you found the channel, because frankly, we're surprised that you did. It's only the most comprehensive daily space weather and detailed imagery of the sun that you'll find in the known universe. Today's featured product is not the one I'm wearing. Here's the one I'm wearing. It's Smasher Price, my first scamdemic. Today's featured product is Do Not Pole Vault the Caldera, our top seller. The one I'm wearing is one of the original pieces of merch that we ever created. And what we're saying with Do Not Pole Vault the Caldera is, if you're going through hell, keep going. No matter how bad times are, they are certainly capable of getting worse. However, if you are going on a volcanic vacation, leave the vault pole at home. Do click the links below this video and on the homepage at smashomash.com. Welcome to the Neo-Renaissance. Do not pole vault the caldera. This public service message brought to you at massive personal risk and expense by yours truly and Smash staff. Give her a raise by picking up some merch. Thanks to everybody who has. You're helping to support the channel. You can also visit our links at smashomash.com, the official homepage of the Smash News Network, least busted name in news. We're pretty spaced out here, and again, welcome to the Neo-Renaissance. You can find all kinds of links to original music there at the Spotify link. That's Golden Cat Productions, the record label that I formed back in the year 2000. You can also find Instagram, etc., Facebook group, Facebook profile. So help out the channel that way. Press the share button on social media and so on. Now, We were, of course, streaming the events that generated that solar energetic particle event on the Twitch channel. And there is a little bit of a recap of that. That is streaming most of the time at smashomash.com/smashteam as well. So there is a series of events happening there, including a solar flare, plasma reorientation features, solar energetic particle event likely generated by one of those features. There could even be an earthly directed component to that there, as we do see a little bit of limb darkening happening. So, but at the moment, not thinking that there are any earthly directed components. If they are, they'll be very diffuse and minor. And let's take a look at yesterday plus today. Let me pause that. Let's take a look at yesterday plus today from the SDO continuum. Mostly stable here. Not a lot of changes happening with sunspots. Another great way to view what's going on is to look at the colorized magnetogram. It really does do a fine job of showing where active regions are forming and so on. And that hasn't been happening in the past 24 hours, but there's certainly been plenty of action in the realm of space weather. So let's take a brief moment to see what's going on croissant Earth. Yeah, Earth. It's croissant-shaped. Stop believing NASA's lies, folks. Stop believing NASA's lies. And just so you know, folks, strangely enough, I think more people believe the Earth is flat now than ever have before. It's crazy. Educated people have believed the Earth is spherical for over 2,000 years. It's just that there are so many people believing so much nonsense on the internet that, well, you get the idea. Anyway, because of population growth and access to nonsense, propaganda, lies, fraud, misrepresentation, disinformation. All right, so here's the volcano rundown. Semeru is exploding. It's a discrete volcanic ash cloud of 15,000 feet altitude. Flight level 150, a 15,000-foot ash plume over Semeru on East Java, Indonesia. Shishaldin, not sure if it's erupting. Volcanic ash not identifiable from satellite imagery. Fuego in Guatemala, exploding. Flight level 170. It's a 17,000-foot ash plume over Guatemala. Sangay exploding. Flight level 190. 19,000-foot ash plume over Ecuador from that. 15,000-foot ash plume over Ecuador from Revenador as it also explodes. It's a flight level 150. Sabancaya, flight level 220. 22,000-footer over Peru, and continuous ash emissions from Ubinas as well are a reminder to not fly your hang glider or bring your vault pole to the caldera at Ubinas. As far as seismic activity goes, here is a convenient 90-day bar graph for you from volcanodiscovery.com. There was one 6.2 magnitude quake occurring in Argentina, just west of the Rio Salado River. There is a location of that 6.2, and it wouldn't have felt like a 6.2 because it was at nearly 600 kilometers estimated depth. We didn't even send emails out about that. There was zero chance of a tsunami, and not a likelihood of that much damage happening either from that. It's showing green on the pager there. 6.2 at Argentina occurred just this morning. So we'll run down the list here and report quakes over a 5, like this 5.6 in the Molucca Sea. That was at 11:48 Universal Time yesterday morning, 12 minutes before noon Universal Time. And from then on, no 5 or greater magnitude events. Just none at all. Until we got to this 5.0 at, is that Papua New Guinea? Nope, Pakistan. So Pakistan had a 5.0 there. That was at 3:06 Universal Time this morning. And then that 6.2 was at 7:20 Universal Time this morning at a depth of 597 kilometers. So a very deep quake. If that would have been at the surface, that would have been like a 7.5, like a 7.5 magnitude quake. If that happened at the surface, that would have definitely been more newsworthy than that deep 6.2. So that said, let's get back to space. Here's some more spectacular imagery from the SDO, 24 hours in ionized iron and helium. Here we've added 171 angstroms to the 304 angstroms wavelength. Great stuff, indeed. And here's another close-up of the western limb where all that action happened. You will notice an event happening here that looks like a CME that could be directly toward Earth. Again, if it is, it's going to be pretty diffuse. But that is where the action has been going on, around the western limb. I think I might have forecast that. Here's a close-up of really a frenzy of activity. And just a quick reminder, the most likely place to see a large flare, including a possible X-class event, would be from this setting sunspot in the northwest. So we'll also show 171 angstroms by itself because it's so aesthetically pleasing. The 171 angstroms wavelength is ionized iron. It's one of the cooler wavelengths depicted by SDO. I mean cooler in temperature and in aesthetic value. It depicts the lower corona. And you can see the way that ionized iron is interacting with the magnetic fields as plasma orients itself to those magnetic fields. And did you know coronal mass ejections flying through space have their own magnetic fields? Yeah. That is what determines how hard of a strike it will be when it does strike Earth. The 10.7 centimeter radial flux now at 171 solar flux units, a little uptick from yesterday. Actually surprisingly low. There is the 1 year graph of the 10.7 centimeter radial flux. It's represented by the black line there. The red line is the sunspot number. That is from Solon.info. Space Weather Enthusiast dashboard here. This is NOAA's forecast. Forecasting for a little bit of geomagnetic unrest early tomorrow morning. Yeah, so there's another CME on the way as far as our channel is concerned. We forecasted that one. So that was, we're expecting another possible CME event impacting tonight. So this is why we were talking about organizing Aurora parties yesterday, because Saturday night will be another night to possibly see some Aurora. So we'll talk more about that here a little bit later. But NOAA's forecast here is just for a little geomagnetic unrest early tomorrow morning, and then that will subside according to NOAA's forecast. We're expecting another significant CME impact coming later tonight, probably somewhere around midnight universal time. So the second CME impact, we're expecting it to be a little bit later in the day than last night's. Anyway, here are the past 4 hours of Earth magnetic moment from space. We are seeing the space weather situation subside a little bit. We did get all the way up to KP 6.67, which is exactly what I forecasted via yesterday's chat. I believe Mr. Bordages asked what the highest KP I expected it to be, and I said 6.6. So 6.67 is exactly where it got to. That happened just earlier this morning, and I wish I would have woke up 1 hour earlier, as I might have been able to see the aurora here at Pennsylvania, but unfortunately I slept through that one. So that's the past 4 hours of Earth magnetic moment from the ground, the full scale. And there may be some substorms there available that have been viewed in the Indian Ocean. Here's North America for the past 4 hours. And again, the events seem to be subsiding here, so we're seeing the field looking like it's weakening. Also the other solar wind parameters, which we'll go over here in a minute. So there are the past 4 hours of Earth magnetic moment from the ground for North America. So here's the auroral forecast. We're just going to let this play because this is one of the many features that you can use on the Space Weather Prediction Center by NOAA. This one isn't known for being as accurate as the maps that we just showed, But there you can see some significant aurora there generated. It looked like the southern hemisphere, the aurora australis, might have been a little stronger. This is one of my favorites. This might be indeed my favorite, or maybe the ground magnetic perturbation maps. This map here is super good because it's showing induction into the power grid. So this is going to show you where you're likely to see spikes in the power. You can see some major spikes up there in northwestern Canada especially. It's showing millivolts per kilometer in the electrical grid system. So this'll, if you see this light up in your location, you might be able to see the aurora there if you have clear skies at that moment. Again, the highest geomagnetic storm condition that we saw was a KP 6.67, which is really KP 6.6, but it's a repeating decimal because it's 6 2/3. So not quite the KP 7 exactly as forecast, and the timing was on also with this one. So cheers. So here's a real-time solar wind, and again, the BZ, which is this red line, has now moved into positive territory. So that's more of a push than a pull, and positive BZ is less likely to produce geomagnetic storm conditions. We're also seeing a dropping off of the solar wind temperature and indeed the solar wind density. So it looks like the trailing edge of that CME is on its way out now. Current conditions are about 400 kilometers per second, a very nominal solar wind speed. Solar wind density here just below 4 at 3.72 protons per cubic centimeter. There are the GOES magnetometers, and the biggest variations happening here during that KP7 moment. No surprise there to all of you plasma enthusiasts. So also some maneuvering happening there by both the GOES 16 and GOES 18, as evidenced by those arc jet moments, where their thrusters create plasma which can mess with the magnetometer readings. So they show those arc jet moments to show that, oh hi, we're not hiding data. There's more data available than we could possibly handle, folks. What we really need is people who understand the data in order to write new science papers and help with things like astrophysics and cosmology. So anyway, here's our top view ecliptic plane field plot. And you can still see this magnetic tug-of-war going on right over here. That is because of indecision in the eastern limb of the sun, as there are coronal holes of both polarities over there, which we'll show you here momentarily. So if you bring up the last image, you'll see the North Pole current sheet. Earth is kind of right in the middle of it at the moment. There it is, North Pole current sheet depicted in green. South Pole current sheet way over there in red. Another one over here in the west. Next hour, line of sight field plot. Polar fields here depicted in red for south and green for north. Solar B field depicted here in blue, and it's looking more and more like solar maximum. Let me give you an idea of what it looks like at solar minimum. So here we went back exactly 4 years, and you can see that how steady the fields are, right? The solar B field here just hanging out quite close to the ecliptic plane there, right around the solar equator. And then the solar polar fields there fixated at the poles. So these are the poloidal fields fixated there at solar minimum. Now this is just a few months before solar minimum, between the transition of solar cycle 24 to solar cycle 25. You can see how predictable the sun is there and how few magnetically organized regions there are. In the grayscale portion of that imagery, that is the sun near solar minimum. And here is the sun probably around 1 year or less from solar maximum. Looks a little differently, right? And that is the solar polar field reversal process happening, during which at the same time you see the sunspot number rising. So all that magnetic organization happening there as the coronal holes show us the reversing of the solar polar fields, which is what we're looking at here, the line of sight coronal hole plot. Here's this magnetic tug-of-war happening in the northeast that I was talking about. A little bit of indecision there as the magnetism here switches back and forth from north to south. And let's take a look at coronal holes from SDO. So there's a 24-hour video. And 211 angstroms is the optimal wavelength from SDO to observe coronal holes. The most well-defined one being this one down here. It is of North Pole orientation. So when we get to the next solar minimum, folks, you can expect to see North Pole magnetism down here and South Pole magnetism up here. That'll be the transition between solar cycle 25 and solar cycle 26. All right, and next, sunspots. Those are important, right? I've heard something about sunspots. They are important. So here's a sunspot situation. We do have a very high likelihood of large solar flares remaining. So the most likely place for a large solar flare is right over here, sunspot 3386. That's my first choice. Second pick would be this one right here, 3387. So those are the two most likely places for a large flare, in my opinion. And here are sunspots yesterday plus today. That is August 4th and 5th to date. So mostly stable there. A little bit of evolution happening with this sunspot group. And certainly some evolution happening with this one. Some very rapid movement up there. Check that out. Look at the rapid motions. So that is the area where a lot of that filamentary activity just occurred. The northwestern limb is the place to watch. So again, there was another solar energetic particle event generated. There is the GOES proton flux, and it's still rising here. So it was a double peak event. And yeah, we'll be having radio blackouts here at the poles once again. Let's show that. All right, so as solar energetic particle events show up at Earth, those get mostly trapped in Earth's polar fields. So Earth's poloidal fields have a tendency to trap those, and in those, when they show up, they cause polar radio blackouts. They emit radiation, and they attenuate. They cause radiation emissions, and they attenuate the D layer of the ionosphere. So here you'll see some absorption showing up at the polar regions as that solar energetic particle event gets stronger. The equatorial radio blackouts there, those are caused by solar flares. There was an M2 class event. And then here not long after that, oh, that's odd. There we go. So there are those polar radio blackouts. It looks like they're minor for the southern hemisphere and pretty significant for the north. So it was like only less than 2 hours there between the solar flare and the arrival of those solar energetic particles. So again, particles moving at a significant percentage of light speed there. That is a solar energetic particle event. And it looks like it's not done yet because, well, it might be done. It might have been subsiding there. So anyway, here's what the X-ray flux looks like for the past 3 days. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Here's a great long-duration double peak event that was associated with that plasma reorientation and multiple CMEs. At least 2 CMEs happened there. Peak flux was around 9:40 Universal Time this morning, and that was right when I was jumping out of bed there. An M2, an M1.99 class solar flare. And let's take a look at some flare wavelengths. So here we've added 131 angstroms to 171. That's pretty awesome. And here's 94 angstroms by itself. These are 24-hour videos, once again, folks. Now, again, we do have some significant sunspots over here in the eastern limb. However, just to reiterate, the most likely place to see large flares is certainly over here on the western limb. So don't worry. We'll be keeping an eye on it throughout the day. And when I say eye on, well, the pun was intentional. Here's that same region in 131 angstroms. And actually, this large flare was from this now set sunspot, a perfect example of how you don't need to see a sunspot in view for it to produce a large solar flare. And let's move on to a sky chart. So here is our sky chart for Lehigh Valley, Pennsylvania. That's what's going on overhead. Wait, let me press now. There we go. There's the current situation. The gibbous waning moon is setting over there in between Saturn and Jupiter. And let's do a solar system forecast. Here's where things are today. There's where things will be in 1 week. We'll have a crescent waning moon by that point on the 12th of August. Today's astronomy picture of the day is the Robin Egg Nebula. So this is believed to be this is a binary white dwarf system, and we're looking at it in chemical spectra here, as well as I think it's visible light. The pink portion is hydrogen, and the blue portion is oxygen. Those darker regions, those are absorption features, probably with other chemical components. The Robin's Egg Nebula, otherwise known as NGC 1360. It is also believed to be a planetary nebula, so maybe the extraterrestrials that people actually believe crashed spaceships here came from NGC whatever it is. That is the apod.nasa.gov astronomy picture of the day. Let's move on here to coronal mass ejections. And check it out. There was a halo eruption there. So that was late in the day yesterday. But if that is an earthly directed CME, it's going to be a very minor impact because there's barely any ejecta visible from that. So the more significant coronal mass ejection came out of the western limb, and that is not expected to strike Earth at all. You'll also see the striking of relativistic particles here on the aperture right at the end. Right there, you can see a relativistic particle strike. That's 92 frames from yesterday, August 4th. And here are an additional 7 frames from today. We'll move on from that quickly. Here is the LASCO C2 and C3. And there's a great view of that spectacular CME coming out of the western limb. It's a big one. And we'll also show stereo A. Stereo A shows some great imagery of this as well. We show this diagram because stereo A and B are so close to Earth right now, it's not helping with trajectory calculations. It's suboptimal. So there's stereo A and a fantastic view from stereo A's coronagraph as well of that CME as it makes its way to the southwestern portion of the solar system from Earth's perspective. Before we talk about filaments, let's talk about our 24-hour videos, which are going to be just fantastic. It takes a lot of work putting these videos together, folks. And, you know, we realized when we started making the daily space weather content that we needed to do more than just get oohs and ahs. That's how we ended up with answers to questions not asked. So this is a common thing that happens in science, folks. You ask questions and everybody's asking the same questions, and as a result, you typically don't get any answers. You end up with, instead, more questions. But the really cool thing is when you end up with answers to questions not asked. So that's what's happened. As I believe I've explained the mechanism that underlies the solar sunspot cycles. It's pretty serious. And when that paper passes peer review, it'll just be the most important natural sciences paper in hundreds of years. No big deal. I don't know why that would cause people to tune in on YouTube or anything, but anyway, there's another 24-hour video featuring 193 angstroms from SDO and the Soho Lasco C2. Here's just 193 angstroms. And let's move on to filaments. We've got some fantastic imagery today of filaments. In fact, we've decided to pick up a new segment. So let's show what we usually show. There is the El Teide Spain ground-based hydrogen alpha imagery. And important factor about this is that, well, it shows the overlapping disk. In other words, it shows prominences. So prominences are important, especially when they're on the eastern limb. But I mean, crown prominences, they're all important, right? So lots of filaments on the solar disk here. This one is now on its way out like this. It has left the solar corona and is now hurtling through space at, I believe, 572 kilometers per second. So, but expect coronal mass ejections to continue. The probability of more happening in the next 24 hours is approximately 100%. So you've got huge filament up here. I mean, you could really call this one filament. I think that is one filament. Here, there's another huge filament over here, and then there's another huge filament over here. You've got this crown prominence down here. That's another filament, and then there are some other prominences up here. So lots of filaments, high likelihood of coronal mass ejections to continue. And did you know that you can also view that in color? Yeah, there's a link right here to the color images. The reason we don't show them is because it doesn't show the overlapping portion of the disk. So it doesn't show prominences, but check out how awesome that shows filaments as dark absorption features there. That is just fantastic. The El Teide Spain ground-based solar observatory, part of the National Solar Observatory. It's got some quality notes, but I think the quality is pretty high. Let us know in the comments what you think. That is totally sweet. Anyway, we've also got our custom wavelengths here. This is 193 plus 304 angstroms. So that apparent halo came from this event right here. Again, there was a little bit of limb darkening there, so if there is another CME headed toward Earth, that will not arrive until midday on the 8th. This more major CME that came off of the southwest, that will not arrive at Earth ever. It is far too far off to the west and south to be an earthly directed CME. And let's continue on as it's bonus features time. Well, it's almost bonus features time. By the way, if you don't follow us on Twitter, you don't get to name filaments after living people. And you also will not see, what the heck is going on? You also will not see our auroral imagery shares. So I put up one of them, but you have to be on Twitter or X or whatever you'd like to idiotically call it. One of the worst rebrands of all time, Twitter now known as X. So you can follow the hashtag name that filament over there, or you can also view Aurora, as we have multiple shares from this morning. So follow us over there. You'll find links on the homepage at smashomash.com as well as below this video. Seems pretty easy. And by the way, if you've completely unplugged from social media, I don't know how you're seeing this video as it is a YouTube exclusive, but we don't blame you because, well, censorship is truly pathetic. And by the way, centralization is dead. So it's not needed anymore. In the age of the internet, why is it needed? It's not needed. Censorship is dead, and so is centralization, and certain companies are moving forward like zombies. Zombie corporations with nobody at the wheel. I don't know what they're doing, but it's certainly not a good job at their own jobs. So, yeah, here the past couple of hours. Again, expect continued activity up here in the northwestern limb. And it looks like another huge filament showing up here in the eastern limb as well. So lots of stuff to go over when it comes to space weather. And here comes bonus feature segment. So we'd like to look at things like satellite charging hazards, because one of the things people talk about all the time is, China has attacked the satellites. There's interference on the satellite for this or that reason. It's because HARP or some nonsense like that. One of the things that causes satellite communications breakdown is charging hazards. And we do have some significant charging hazards right now over places like the Gulf of Mexico, Central America, Mexico, and the Eastern Pacific. So those surface charging hazards, that's when low-energy electrons build up on the outside of spacecraft. It can cause some minor communications breakdowns. That's the satellite's community dashboard. If you want to go monitor that yourself, the GOES electron flux here showing quite low levels, as you may have expected if you are a regular viewer of our channel. Not quite as low as some of us expected. Here's the one-year graph to put it in context, so almost as low as it ever gets. The relativistic electrons there, measured at the F layer of the ionosphere. And here is the forecast model from NOAA. We agreed with this forecast, but the levels turned out to be a little bit higher. So that was surprising to us and to NOAA. Again, that is measured at the F layer of the ionosphere, so we're going to show that next. Feel free to pause the video on this frame if you're not familiar with thermospheric temperatures, electromagnetic radiation penetration, and chemical concentrations in space. Here is the bridge between Earth and space, the F layer of the ionosphere, in raw vibrational frequency. And really, we didn't see as hard of a hit as could have happened. Again, this is all determined by things like magnetic fields. So magnetic field strength and orientation is not something that's able to be forecasted just by simply looking at visible data on the coronagraphs. We'd have to have actual measurements of it. So basically, we don't know what it's going to be like until it gets to Lagrangian point 1, only 1 million miles from Earth. So when it's 92/93 of the way from reaching planet Earth, that plasma does show us a signal. But until then, it's typically not able to be modeled. This is something that ESA and NASA are working at in the future, as NASA wants to forecast every coronal mass ejection. We hope they're watching our channel. That might be a wise idea. They've got lots of skin in the game, known as astronauts, as people in space are the most susceptible to the radiation generated by these CME impacts. So that was the raw vibrational frequency. Here's the anomalygram, and as forecast yesterday, you'll see a lot of red showing up on the anomalygram. It depicts anomaly in megahertz from a 30-day median, and those red areas are low-frequency anomalies. That is where the ionosphere is puffing up because of all of that space weather. You can expect this to continue for the next 24 to 36 hours. Here is the latest image. That's 11:30 universal time for the ionogram, and there's 11:30 universal time for the anomalygram. Total electron content shows free electrons from 12,500 miles of altitude down to your handset. Those free electrons in between your GPS satellite and your handset cause signal refraction. So this is a multi-layer signal here, folks. So this is helpful for Earthlings to figure out if their GPS is going to work well, but it's also important for space weather because it does tell us things about what's going on with the magnetosphere and so forth. So we do have some significant anomalies here south of the African continent there, around the Southern Ocean and Antarctica. But ultimately, the free electrons there are fairly organized. So there you see those significant anomalies down here by the Southern Ocean and Antarctica, south of Africa, the Indian Ocean, and the Atlantic. We'll let it play through one more time, as there are some significant anomalies there. Don't miss them. There you have it. Also some significant nighttime GPS errors there. total electron contents tend to be the highest around the equator at noontime. Here's the total electron content anomaly from the 10-day average over North America, and we're seeing a continued signal here around the Cascadia fault zone. So that certainly looks like an Earth-generated signal. We have seen some possible foreshocks there. So the possibility of a 6+ magnitude earthquake might be foretold by this likely Earth-generated signal. It's not because space weather is causing earthquakes. It's because an Earth-generated signal may be showing up in the space weather data. So that's the CTIPE anomaly from the 10-day average over North America. And again, you can see that signal there around Vancouver. Possibility of a 6+ magnitude earthquake in the Cascadia fault zone in the next 4 days. By the way, so far the success in forecasting this way has been just this side of 0%. But we entertain the possibility, as in science, you better have an open mind and you better not be ossified in your beliefs, or you're not doing science, you're doing dogma. So here's the latest intensitygram and latest colorized magnetogram. Here's the rock back. Most likely place to see an X-class solar flare once again is right here. Second most likely place is right here. Third most likely place is right here. Also somewhat likely over there to see a large flare. So that is the current situation. Those are the magnetically complex sunspots. Let's take a brief look at this one in colorized magnetogram. It is beta gamma delta class, the most likely type of sunspot to produce a large solar flare. By the way, if you haven't checked out nullschool.net, nullschool.net will show you the auroral predictions. We actually brought this back to when it was near its peak. It was earlier this morning. Some quite significant aurora there. And if you bring it to now, it has subsided quite a bit. Let's take a look at winds as we have now moved into the meteorology segment of this video. We'll show you all kinds of weather forecasts and weather data. So let's switch to our surface wind map. There's the surface wind scenario for the eastern world. It looks like this typhoon has lost a little strength and moved a little bit toward the north there, toward the southern islands of Japan. Here are the jet streams of the east. Shout out to our viewers from all around the world. The jet stream blowing backward here over the western Pacific and the northern Indian Ocean. Here are the jet streams of the central world, like Europe and Africa and the Middle East. It looks like a cold day in northern Italy. The Italian Alps here having some cold weather blowing down from the UK. Here are the surface winds of the central world. Here are the surface winds of the west. And here are the jet streams. Jet stream also blowing backward here across the Atlantic. And let's take a brief look at Saharan dust, as this does affect the likelihood of tropical systems forming in the central Atlantic Ocean. And again, there is a lot of Saharan dust. Check out the Saharan dust totals. That is a lot of dust. So that will have a tendency to tamp down systems. We also have an anticyclone rotating right here. So the likelihood of significant hurricane behavior showing up in the subtropical Atlantic Ocean is really low, really low. Once again, if you enjoy the content, don't forget to visit our website. By the way, if you want to share imagery of the aurora and things like that, the best way to do it is to do it on Discord. So right on the home page there, you can find our Discord channel. You need an invite link to join a Discord channel, and that's the permanent invite link right there on the home page. If you want to send me an instant message, that's the place to do it. You can also send imagery on to Instagram or to Twitter. The best way to do it is to tweet and to tag us as opposed to send a message, because there's so much spam coming in. So that's the best way to do it. You can leave comments in the Discord channel directly, or you can send instant messages that way. And let's move on to our pressure maps. Here's what's going on over the U.S. in terms of mean sea level pressure. We do have a significant low here south of Iowa City near the Iowa, Illinois, Missouri border. And also another low here over central South Dakota. Here is clouds and fog over the Americas. And if you think mankind is able to control major global weather patterns, you should take physics. You should take certainly physics 1 and 2, because your understanding of things like wattage is deeply flawed if you think mankind is able to significantly alter the jet stream and things like this. It's just ridiculous. And if you think there are chemtrails up there, where are all the pilots and chemicals and truckloads of chemicals and planes that are able to do stratospheric injections and your understanding of meteorology? Where are all of these things? It's not real. It's nonsense. And no, I'm not going to visit Dane Wigington's website. So here's our smoke map scenario. Smoke them if you got them. There is a lot of smoke in Washington. Dag. So some very, very thick smoke there in Idaho, Washington, Oregon. That is firesmoke.ca. If you're wondering, it is showing a forecast there. And let's move on to the weather.gov map. Yeah, weather.gov. If your location's lit, click your location. We've got some significant weather warnings here. We'll briefly show you the key in case you're not feeling like going to weather.gov. I don't care. I've showed you the weather warnings and the key from weather.gov. So here comes some forecasts. This is the GFS 72-hour total accumulated precipitation forecast. We're showing it first because there is significant flooding here in the forecast for not only eastern Pennsylvania, but also Indiana, Illinois, Wisconsin, Iowa, and especially South Dakota. South Dakota expecting some areas there with 6 inches of rain coming. So realize that. Also, it looks like 4+ inches of rain coming to Pennsylvania here. So significant flooding there in the GFS 72-hour forecast. That is in inches, by the way. Here is the 72-hour GFS pressure and precipitation forecast. Pennsylvania is going to get kaplastered in about 3 days. Here is the temperature anomaly forecast, since there are so many heat advisories. Temperature anomaly forecast in degrees Celsius for the GFS 72-hour model. And we'll also show the jet stream. So the jet stream is going to dip down here. You'll see some cooler temperatures in the north and northeast. Warmer temperatures south of that jet stream. And here's lightning. Heavy lightning there across Kansas and Missouri, especially over the past about 10.5 hours. And here is the current situation. So that is a real-time lightning map from lightningmaps.org. It's moving into Tennessee, folks. Significant cell there north of Dresden. Also west of Springfield, Missouri. And there is the full view. If you enjoy the content and you'd like to support the channel via a subscription service, the best way to do it is via the Smash Team site, smashomash.com/smashed. We launched it back in October of 2021. The best value is the annual paid-up subscription. It's almost like getting 4 months free, as it includes complimentary merch. Not free merch, complimentary merch. So check that out. If you want additional content, that's the place to get it. smashomash.com/smashteam. We built our own because, well, It's got greater capabilities than any other paywall. So we saw the writing on the wall, and we built our own stuff. We'll close out this video with the latest U.S. Doppler radar. We'll briefly show the full 50-state view here. The full 50 states of ALSA, the allegedly United Statists of America. By the way, laws still do apply to reality, so just so you're aware of that. Even if they're not enforced or if they're selectively enforced, laws still apply. The Constitution is still a thing, and some people actually still believe in upholding it. Let's show a brief close-up of these three systems. They are moving in different directions, by the way. This one looks like it's moving a little bit to the northeast. This one's moving to the southeast. And this one's moving east-southeast. Anyway, there's the lower 48 view. Here is the clouds and fog scenario. That's shortwave radiation, 3.9 micrometers. And here is water vapor, 6.19 micrometers. It shows all the water vapor, and you can expect clear skies over the northern Gulf of Mexico there. Anticyclone type system rotating clockwise, as they do in the northern hemisphere. Also an impulse of dry massive air pushing this system, and of course pushing these systems as well. Dry air, it's more massive than moist air. That's why you have high pressure on a clear day and low pressure during a hurricane or during a thunderstorm. The pressure drops because water vapor is less massive than atmospheric nitrogen, or N2. Here's your recap, U.S. Doppler radar. Clouds and fog. And there is water vapor. And here is me closing this thing out. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We are frankly surprised with the disgusting, sickening, putrid, ridiculous, unconstitutional, un-American, criminal censorship on the internet. Demand that people do their jobs, and demand that publicly traded corporations stop misleading investors. Anyway, in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker again. All the stupid crap I've heard has caused me to jump in.